Well, here we are again, CCNA1, second to last chapter, chapter 10, and it's my least favorite one. And so this is the application layer. Okay, so what are we going to explain? How functions of the application layer, session layer, and presentation layer work together to provide network services to the end user applications. Describe how common application layer protocols interact with the end user. Describe at a high level common application layer protocols that provide internet services to end users, including WWW services and email. Describe application layer protocols that will provide IP addressing services, including DNS and DHCP. Describe the features and operation of well-known application layer protocols that allow for file sharing services, including FTP, file sharing services, SMB protocol. Explain how data is moved across the network from opening an application to receiving data. Sounds like a good time, so let's jump into it. Alright, so the OSI and TCP/IP models revisited. So hopefully we've hit this pretty hard, so hopefully you remember we have 7 layers on the OSI, and the last 3 all fit into what we call the application, but in the OSI they're called session, presentation, and application. Alright, so that's what we're talking about today, is the TCP/IP application model, which is going to include all of these things. We've talked about the others in the past. Here we go. Application layer. What is the application layer? Well, what we're doing right now is the application layer. With me, with this mouse, we're on the application layer. The application layer is closest to the end user, as shown in the figure. Okay, some stuff happening at the application layer. DNS, domain name services. So what is DNS? Well, you can find it right here, right? Bang. And I don't know where are we going here. We're going right here. And so we hit this, and if we go into our properties where we set our IP addresses, we see this DNS thing. But what is this DNS thing doing? Well, we don't need it for network connectivity. We need it to go to Google or any other website. So what it's doing, instead of me having to memorize IP addresses such as 8.8.8 for Google, or who knows what this is, let's find out what this is actually. We're gonna find out what this is. So CMD, how we use DNS is we say NS lookup, and then we put in whatever we're doing. And so it goes to firewall. I can't find this. Okay, non-existent domain. So let's shorten it down to just the domain. Oops. We want to go to just the domain. So we don't need this HTTP. Okay, NS lookup. And so if we couldn't just have it send us to, you know, static course assets, S3 Amazon, like not like we memorize that either, but it would be 54.231.81.16. And so how I did that is I just said NS lookup to the actual domain name, and that's our DNS tool. Okay, so NS lookup, and just like IP config is our IP helper, that's our DNS helper. Or it's our DHCP helper too, I guess. Anyways, back to the fun. Our next thing is hypertext transfer protocol. That's HTTP, as we had in front of there. Actually, we had HTTPS, which is the same thing but was secure. So it's actually encrypted, and that's what we're going to see nowadays. Simple mail transfer protocol is another application, and this is the application that we receive mail through. That or POP. Okay, Post Office Protocol, POP. Maybe you guys have seen this when you set up your smartphones for email. I don't know. Then we have DHCP, Dynamic Host Configuration Protocol. That's what automatically gives us IP addresses. Then we have FTP. That's what allows us to download files. Internet Message Access Protocol, IMAP. That is another... Oh, I was wrong. Okay, I said SMTP was receiving mails. That's actually sending mails, as it says transfer. And POP is receiving mails, and IMAP is also receiving emails. Okay, and we're going to find out the differences in there. And then we go to the presentation layer. So what does the presentation layer do? It formats or presents data from the source device into a compatible form for the recipient device, compression of data in the way that it can be decompressed by the destination device, encryption of the data for transmission, and decryption of the data upon receipt. And so some things we can see in there in the presentation are stuff we can see basically. So we have QuickTime, MPEGs, GIFs, and JPEGs, and PNGs, right? So pictures and videos basically is what we're seeing in there. And hey, if you don't like the way I say some of those words, well, get over it. Lots of arguments on the internet about how to pronounce them. Okay, so finally, do we have our session? Nope. The session must be down here. The session, as the name implies, functions at the session layer to create and maintain dialogues between source and destination application. The session layer handles an exchange of information to initiate dialogues and keep them active, and to restart sessions that are disrupted or idle for long periods of time. Okay, so that's the session. Alright, so then we go back to these protocols. So DNS, as I said, this protocol resolves internet names to IP addresses. Alright, then we have Telnet. This is used to remote into devices and is bad. Okay, this is one way we can monitor. We could, if you wanted to command line a computer, you could Telnet into it. It's one way we could manage our network devices, but we would use SSH as it's encrypted. And Telnet's not, so our passwords and everything would be coming over and easily intercepted. Insecure. Okay, simple mail transfer. This protocol transfers mails and attachments. DHCP, protocol used to assign IP addresses, subnet masks, default gateways, and DNS servers addresses to a host. This thing, you probably learned to love it. If not, by CCNA2, when we get to DHCP, you're going to learn to love it, because you're going to get sick of statically assigning, because this thing, you have less likely, to make a mistake. Oh, I was in the wrong network, right? We just programmed this for the right networks, and it works. That's the nice thing about DHCP. Until it doesn't work, then we hate it. Hypertext Transfer Protocol, HTTP, that's how we get websites, right? File transfer, a file protocol used for interactive file transfer between systems. TFTP, this one is a UDP protocol. Similar to FTP, this is how we flash devices. We can save configurations, or load we can have a TFTP server that will actually load the operating system into our routers or switches. But I don't know why you would do that. Bootstrap protocol. It was before DHCP. Post office. It's the only way I like to use email, but it's less and less common. Difference between POP and IMAP. IMAP saves email on a server, so you can delete it from your phone and it's still on the server. POP just deletes it. Okay, when I hit delete on my phone, I want to delete it off the server, so I don't have to go into the server and delete it. But anyways, that's what IMAP does. So on your phone, the IMAP, when you hit there's no delete, it's just like archive or whatnot. Alright, so types of networks. We have peer-to-peer networks and client-server networks, right? So a peer-to-peer network just means that we don't have a main server. All these guys can work as a peer, right? So if this computer shuts off, we're not getting this printer anymore, right? There's not a dedicated, it's just kind of a real makeshift network. Peer-to-peer networks, stuff like Bitcoin, right? Because there's no dedicated server, it's all relying on the people. BitTorrent, I don't know what else. Well, here we go. Well, we got some more right here. What uses peer-to-peer? Well, one way would also be sharing. If I shared a printer from this computer right here to other people, it'd be peer-to-peer, because there's not a client doing it. So it's relying on my computer being on to get that computer. Instant messages, IM programs can be peer-to-peer, or downloads. Come on. Okay, so this is actually a test question, so memorize these because they're really stupid names, but for some reason it's important. eDonkey, eMule, Shareaza, BitTorrent, Bitcoin, LionShare. Basically, these are just illegal file sharing applications. Old ones are LimeWire, Morpheus, WinMX, whatever, Solo. Anyway, so basically, peer-to-peer this guy can get it from one server, or they can get it from others. This is how, like Bitcoin, you have to check your out. I mean, that's takes like days when you first start a Bitcoin account, so that you can I don't know, authenticate your wallet or whatnot. Anyways, that's for another day. So applications, HTTP. Alright, so how does HTTP work? Well, when we request, it sends it to the server sends it back, right, and we get our web page. But how does it actually work? Well, we have three ways. We have get, post, and put. Okay, so get is when we request information, post is when it sends us information, put is when we change HTML information. Post and put are used to upload data files to the web server. Okay, get is used to put uploads resources or contents to the web server. For example, if a user uploads a file or image, website, a put message is sent. Alright. Get is a client request for data. That's basically, read through this. They ask you some pretty hard questions on the test, but it'll be, unless you become a web design guy, it probably isn't that important. But hey, if you're interested in that, good on you. Alright, so then we go to SMTP. So SMTP is what is going to send emails, right? And then we're going to retrieve it using their POP or IMAP with our client. But so SMTP sends it to different mail servers. It's the sending. Then POP is make sure you do these port numbers. SMTP port 25. You'll be testing on port numbers throughout your life. Just start memorizing them. HTTP is 80. I don't know. There should be port numbers at the end of this somewhere, or look them up on Wikipedia. Probably the best. SMTP, this thing's sending, and then POP, we can use a some kind of mail software, like such as Outlook, to access our POP3 or our IMAP. Alright, so POP3, remember that's where the email, as soon as you click delete here, deletes it on the server, whereas when we go to IMAP, this is IMAP. IMAP's here. IMAP saves it on the server, so when you delete it from your phone or from this, it still stays on the server until you log into the server to delete it. So your other devices really don't matter. So if you have a habit of deleting important emails, IMAP is the one for you. Alright, so DNS. What is DNS doing? It searches for a number. There's different kinds of DNS queries. Let's see, where is it on here? Right here we have A for an end device. NS is a name server. CNAME, what this allows us to do is have one server represent multiple websites. MX is for mail. Okay, so these are just, we'll send different types of queries. So if we're looking for a mail server, if we're putting a mail server address in for our website in DNS, we do use an MX record. CNAME is going to allow us to have multiple websites hosted by the same IP address. NS, we're going to go to a root authority looking for an address. A just means it's a host. Okay. DNS hierarchy. Alright, so we have a DNS client, and it could go to a local DNS server such as at lcsc.edu or something like that. Then we go to top level servers, right, such as the big boys. We can look for, we can go to like these top level domain servers. Then we go to the root DNS, right? So the root DNS has all the .coms. This one, well, there's specific ones for just .coms, .orgs, .aus, whatever. There's so many nowadays. And then our local our local DNS will have the devices, the DNS we use for local devices in our network, and that is very basic use, but that's my basic definition. Take a good read on there. NSLookup, I already showed you guys this, but that's our DNS tool. It will show us, we can either we can do a reverse lookup and look up an IP address to a name, or we can look up a name and it'll give us the IP address. Go ahead and try this out. That's our DNS lookup tool. So now we get to DHCP. Okay, so DHCP automatically addresses stuff, and hopefully you guys are familiar with this. If not, read through here. DHCP is used all over the place. How does it actually work? Okay, well, it first sends a DHCP discover. This client sends this. This is a broadcast, so it would send it all over the network. Then each DHCP server is going to send a DHCP offer. Then the client does another broadcast saying DHCP request, and so it's where it says, hey, I want to use this DHCP server and this IP address. Why is it a broadcast? In case there's multiple DHCP servers, so this guy doesn't think it's giving it an IP address too, just this server if it's picked this one. Then the DHCP server acknowledges that request. When it does, that's called a lease. When the lease renews, this actually is no longer a broadcast. It's a unicast to the server. Sends the offer again, unicast back with requests, and unicast with the acceptance. So if you want to see that, that's what you can see in this DHCP and packet tracer. You can go into simulation mode and it'll actually show you how that works. Alright, so FTP. FTP we can use through command line, web browsers, whatever, to download files. A lot of times this is how we put files on web servers or get files from web servers. FTP is a TCP protocol, so you may notice you're going to get your stuff there. The client establishes the first connection to the server for control, consisting of client commands and server replies. The client establishes a second connection for the server for actual data transfer. So what this means is TCP runs on both 20 and 21, and so 20 is for control, logging in, and 21 is for sending data. Okay, that is a basic explanation of FTP. SMB is where what we call a map drive or something like that, where it actually simulates a disk being connected. So we can map to a server, and where we can save everything just like it's a local drive on a server. That's SMB. It's at a block level rather than a file level. And so this would be used for, actually this is still a file level, but iSCSI would be a block level. But anyways, what it's doing is it's for larger files over long times. Like we would put this on there and it'd start up each time. Let's see if I have a disconnected map drive right now. Go to my PC, let's see, and I don't. This used to be right here. This used to be a map drive. I can't find it right now because I took that server off. You could also use what's a UNC, and that's just a network path, which works in a similar fashion. But SMB is just a protocol allowing me to map a drive over the network. So SMB messages can start, authenticate, and terminate sessions, control file and printer access, allow an application to send and receive messages to others. And so if you read this, SMB works with Samba in Linux. That's what it's called in Linux, Samba or Unix, and it allows us to share with those types of servers or operating systems. Anyways, so that's how that goes. What do we have here? Send a message through the world. Okay, so this, I've explained this in class before, but what this is showing you is how we actually send a message. So it goes from the application layer, right? And then the transport layer divides the stream into segments and adds a TCP header to it. So then we get to the transport layer of the segment, and it puts an IP address on it, right? Destination IP address, and then it is converted into frames, and then bits, and sent from frames to bits as we keep going, right? Let's see if it goes on with our video. We've talked about this. Alright, so here we go. We finally get to it. So we have our 1s and 0s getting sent through. And so it sends it through. This then builds packets again, breaks it back down to frames, sends it 1s and 0s, packets, frames, bits. And then this server over here is going to build it from the network access to the internet to the transport to the application. And that's basically what it's telling you. Then when we have I don't know, let's just talk about transport layer. Anyways, you can watch this video. It's very simple. Anyways, but it's a silly video that does a pretty good job of explaining how networks actually work. But that was the application layer. There's a lot in there. I don't find it particularly important for your certification or most things you do. I mean, you need to know how all these important applications work and how they go across the internet. But if there was one chapter I was going to study a little less, it'd probably be this one. Anyways, if you have any questions, send me an email. One chapter left. Yeah!